Hi, so I'm Mustafa, and I'll be talking about my master thesis, which was about data visualization in VR. And I work as a designer here, but for my thesis, which was also in design, I created a library for doing visualizations in VR. So the whole idea of the thesis was kind of combining information visualization or data visualization with virtual reality. And the reason I wanted to do that was just to try it out first and to check if like 3D visualizations, which are kind of hard to use on 2D screens, can they be used effectively in a 3D medium like virtual reality or Google Glasses or AR glasses. So that was kind of the motivation, and that's where it started off with. And once I was doing that, I first started off by noting what are kind of the advantages which can be used for the which can be leveraged for information visualization in VR. And one of the basic one is like additional dimension, that you have 3 dimensions in VR, and in 2D screens you have 2 dimensions. So basically you can have XYZ scatter plots in VR very easily, whereas in screen it's a bit harder to plot them. Second was like the infinite canvas size, which is that in a screen you have like limited amount of pixels, but in VR it's kind of you have a large canvas area to play around with, so you can have like bigger graphs. You can arrange them in a more intuitive and more attractive way, so as to say. So you can have graphs behind the users on the side, so they can rotate and check it all around. So it can have like much more intuitive layout that way for the dashboard or something like that. Third one is like immersion, which is, since VR being an immersive medium, it kind of helps when you have like complex data, in a way that when you are immersed in the data set, you can kind of walk around to the graph, rotate it, check it around from different point of views. So it helps in understanding the data set a bit more. This is not very helpful for like smaller data sets, but for like larger data sets, which are kind of used in data science and all, this might be much more useful. And the fourth one, which is not essentially specifically for the information visualization, but generally use of VR is kind of collaboration, which is that multiple people can connect to the same interface and be present in the same area and collaborate around for the graphs and discuss about different data sets there. Apart from these, there are some specific things which can be used for designing visualizations in VR, which are like really helpful. So one of them is that it's like really good for designing big data sets visualizations, because as I mentioned that there is no limits for the X and Y axes. You can have bigger graphs, so they can be less cluttered. There can be less over plotting for stuff and those kinds of things. So for bigger data sets, it's like really useful. Secondly, it also helps in like giving context to the data. That, for example, if you want to show something which is like, let's say 100 meters long. So if you want to show the height of a building or something like that, in VR, you can actually plot that tall of a building. So you can show 100 meters as 100 meters. You don't have to scale them down. Or if you want to show that how much time, for example, Usain Bolt took for running 100 meters, you can show the actual data in like real time in a way in VR, showing actual 100 meters track there. For that reason, it helps in like providing good context in a way, and helps in like understanding the data a bit better. And also in this, you can also use like actual 3D objects. So if you want to show, let's say, a human, you can actually use a 3D object of a human to show that, rather than just making a square or a circle to represent them. Third thing is that I don't think so that 3D visualizations are gonna replace 2D visualizations as such. They're gonna still exist together, but they can be used together in a very intelligent way. For example, if you think about these two plots, which is like a scatter plot matrix and a 3D scatter plot. So one can be used for correlations and stuff between two axes, whereas other one can be used for clustering. So they can be used like that. And also one can do is that they can have a 2D graph at the bottom, which user can interact with, and it can show the corresponding data on the 3D graph. So they can be used very effectively in like together, rather than just using them separately in a way. And I think so the biggest advantage of 3D visualizations are in geospatial data. So you don't have to use a projection. You can actually show the map coordinates on a globe. So that's one big advantage. And secondly, there are certain map visualizations which become like really cluttered when you have just X and Y axis. So what you can do is you can imagine a map on the floor, and then bar charts can be on the map going on the z-axis. So it could like reduce the amount of clutter and make the graphs a bit more clearer. And in the same time, in terms of geospatial, it can also be that if you want to visualize this room, you can, by saying that what is the air quality in different parts of this room, you can actually visualize the actual areas when the user puts on the VR headset. So you can also visualize here, as mentioned earlier, a real scale model of a reasonably sized area. Apart from that, there are some like limitations which are like really hard to kind of avoid or should be avoided if possible. The first one is like occlusion, which is since it's a 3D screen, if there's something behind another object, it would be occluded. So if someone is standing behind the pyramid, I won't be able to see that person there. And same's the case with a 3D screen, that if a data point is behind another data point, it won't be possible to see that data point that clearly. This exists in 2D also. The best example is the scatter plot, where you have dots over one another. But in 2D, it's slightly easier to understand because there's no z-axis, so you don't have to have that much cognition. But in 3D, this effect gets exaggerated in a way. Second is like the simulation sickness, which is like a problem with VR. Mostly VR games also faces this problem, which is like you feel motion sick when using VR headsets. So one way to avoid this is not using very heavy animations in the graph, so as to say, or not making the user move from one point to another very frequently, but to keep them stable as such. This is something which is related to the technology, what we have right now. So the screens are not very sharp right now in VR. So the readability of a text is an issue. At the same time, there's an issue which is like, we are not very good at reading text in a 3D medium as such. So we need proper, like we need some background and some stability when we are reading some text. So that's another issue. The hope is that the pixelation and that thing would improve with better screens and better headsets. But still, there needs to be a background and they need to be a bit more stable in VR. And fourth one, which is kind of not exactly a limitation of the medium, but it's a new medium. There's no standardization in the controllers or anything. So it's a bit hard to like create kind of a visualization which works uniformly in all the kinds of different headsets per se. So these are kind of some minor limitations as such. When I was doing this, I sort of decided to create a library, JavaScript library for creating visualizations in VR. Mostly focusing on like standard visualization techniques like bar charts, scatter plots, but extrapolated in 3 dimension. So, and it's kind of, the reason which I used WebVR was that A, it's platform independent. So I don't have to worry about like Vive or Oculus or anything because it runs on the browser. B, I can use like other JavaScript libraries, like for example, I'm using D3 for doing some layouting algorithms and stuff. So I can use those for to leverage their functionality. Whereas if I'm doing it in Unity, I might have to code it like from scratch in Unity, those algorithms. And third one is basically accessibility, that you don't necessarily need a VR headset. Since it's WebVR, it runs on the browser, you can also see it on the computer. It's not necessarily needs a VR headset. Although the interaction and the experience might not be as good, but still it's visible. I basically created this framework, which is kind of a combination of 3 libraries slash technologies. So the first one is React, which I basically use for DOM manipulation. A-Frame is basically a WebVR technology which was created by Mozilla in 2015, which is very much like an HTML declarative language. So this is basically an A-Frame scene, which can be just like created and you can play around it. And the code something looks like this. So it's very much similar to like how would you code an HTML language. It has like predefined things which you can say that scene is a 3D scene which you need to define, and then you can say that you want to place a box somewhere in XYZ coordinates, what should be the size, the colors. So it's like super simple to learn as such. So I use A-Frame for the WebVR stuff, and then I use D3 mainly for kind of data manipulations and for layouting algorithms. For example, I have force-directed graphs and heat map, tree maps. So rather than like thinking of writing the algorithms myself, I thought of using D3's algorithm for those kinds of stuff. And also for things like making accesses and those kinds of stuff, D3 has inbuilt functions for those kinds of things. So I used the D3 for that thing. And based on that, I basically created a React component, which kinds of is divided in two parts. One is scene and one is the graph. So scene part is the place, and it's kind of, I've used kind of a JSON kind of a structure because the idea was that I wanted people who are not necessarily hardcore developers to also be able to use that. So I kind of used JSON kind of a structure to define how do you define a scene and how do you define a graph. In scene, basically you define what is the skybox, what is the color and all those kinds of things, the lighting system which you want to use, the camera position and how it should be placed, and the flow of the scene. So it's a very basic scene as such, and the idea is that the scene prop is not necessarily required. So you can define your own scene, which is much more complicated, and then you can just place the graph in a accurate position, so as to say. And then you have the graph, which has like these different features, which are what is the type of the graph, which defines whether it's a bar graph, scatter plot, line chart, or something like that. Then you give the property of the data sheet which you want to use. So different columns, what are their data types and all these things. And then you style the graph like position and the size of the graph. And then you define the mark. So mark is basically, in a bar chart, a mark would be a box. And then you say what the height maps to, what is the color mapping to, if it's a standard color or not, what is the XYZ coordinates mapped to the thing. For a scatter plot, a mark would be, let's say, a sphere. And then you say what is the radius mapping to and all those kinds of things. And then the last thing, which is like axis, which just says that if you want to show the axis or not. So currently, basically, I created all these kinds of different charts which are there, and I sort of divided them in like 3 parts. So the top 2 rows are kind of standard graphs, which are just a 3D 3D interpretation of the 2D graphs. So you have all 3D bar charts, point clouds, and scatter plots and stuff. The third row, for example, is the mathematical plots, where you can define some equation, and then it plots that equation in VR. So it can be of z as a function of x and y. It can be x, y, z as a function of t, or something like that. So there are like 4 kinds of things which I've created, and the last row is basically visualizations, which are kind of geospatial visualizations. So there you basically define like how you want to plot data on the map. So there are like prism maps and bar charts and all those things. And then basically I also created this kind of a guideline for it. So when to use what kind of a graph depending upon what kind of task needs to be performed. So if you want to do correlation, then scatter plot might be the better option. Or if you want to find the distribution, then bar charts might be the good option to go with. And then there's the interactivity part. So one of the things in VR is that you can explore the graph by just walking around it. So you get to see like the graph from a different point of view. You can change it from top view to side view to the front view. So that gives you another dimension to explore the graph and look at the data from a different point of view. Then there's teleportation, which is just you click and jump to another area. So if you have like a bigger scene, you can jump from one area to another by just a mouse click. And then there's mouse over effect, which if you if you point towards an element in the graph, let's say a box in a bar chart or a dot in the scatter plot, you see the data point which it represents. So this is what it is right now. And then basically, I basically created a example sheet where there are like these graphs here, which is like a storybook. The idea is that these are all online and you can play around it. So this is kind of a graph which just plots, I think, so x squared plus y squared, z equal x squared plus y squared. And then the code is basically here, like how the graph is defined. So it's just a React component which you need to call in there. And then right now I'm kind of working on some other data types, other visualizations also from that. So I'm kind of working on making the map. Right now I have a plane map, so I'm kind of trying to make a spherical map so you can have like actual a globe there and then explore that data. And also trying to add animations in this. So right now there is no animation feature. So I'm trying to add animations for this. And yeah, that was about it. And it's completely open source. It's on GitHub and there's an NPM package for it. So yep, that's about it. Thank you.
Awesome stuff. Do we have some questions?
First of all,
what the hell? This is wild. I thought, oh, there's just visualizations, and then it was like, oh, and it's also a component, and also you can play in the browser. It's like, wow. Um, I guess one question I have right now
Yeah.
is, oh, what does the development cycle look like? Do you usually do it in the browser? Do you do it with a headset? And also,
Right.
how do you explore these visualizations?
So I basically borrow the Microsoft MR headsets here, which I think so is really good for development because you don't need light boxes or setup. So I basically created it all in my browser for the first go. And then when I was testing on VR, what I was doing, the headset was always on my head. And I was just putting it up and down because it's like really convenient with MR headsets that you just put it on your head and then you can play around it. You don't have to do anything else. So I would kind of recommend MR headsets for kind of testing it out because you don't need any setup and you can sit on your desk and do everything you want to do.
Hey, thanks. Looks great. Any plans for like 4D visualizations in 3D?
I don't know it's possible to 4D spatial visualizations, like
Yeah,
adding a fourth dimension as a space.
yeah. Or like mapping it onto 3D so that you can maybe traverse in the 4D by
I
projecting it to 3D
I haven't tried
somehow.
that because I haven't thought of it first. And I think so it might be a bit harder to understand because mapping 3D on 2D is still easier because we kind of see the third dimension as humans, but we don't see the fourth dimension. And I don't know if it even exists. So we don't know if it exists or we can see it or not. So that's the idea with time, with adding animation so that time which is seen as a fourth dimension can be used using animation.
Right, yeah.
So that's why I'm kind of working on adding animation for that case, but not as a spatial dimension. No.
Okay. Another question. Is there support for like level of detail as you move in the, if you want to move in the graph or zoom
Yeah.
in or something like that?
Right now,
Is
no.
there, okay, is there a callback or anything so that
No,
the
not right now,
client
no.
can like
And
get the zoom parameters and adjust the data?
that would be a good idea, but I haven't implemented it. But
Yeah.
yeah, that would be a good idea to add a callback or something like that.
Yeah.
Yeah.
Okay, thanks.
Something more on the design side, actually.
Yeah.
I love that you had this graph of, or this
Yeah.
cheat sheet that says, hey, which graph do you pick? As far as I understand, this is a pretty new field, right? Like VR visualizations.
Yes.
How have you gone about like finding best practices, or even like, I mean, I imagine you've like come up with things yourself too.
So I've been working on data visualization for a long time. So if you see, there are not many new visualization techniques as such which I've focused on here. There are some which is like, there's a time series in 3D, which basically plots one time series on x-axis and another on the y-axis and another on z-axis. So you see it as a plane. So there are these kinds of things, but there are not like many very kind of new innovative visualizations as such. So what I've done is I've kind of extrapolated the knowledge from 2D to 3D. And then from experience, you just like gain that, okay, the only addition you're doing is you're adding one dimension of data to it in a way. From that, you kind of understand that what it could be used for and those kinds of stuff.
So you mentioned A-frame.
Yeah.
I was just curious if you can combine this with larger A-frame scenes and
Yes,
their
you can.
methodology.
So the idea here right now is that the scene prop which is mentioned, it's not a compulsory prop. So what you can do is you can define your own A-frame scene and then just put it somewhere in between the A-frame and then define the position you want to put that graph into. So let's say if there's a scene for this room and there are tables which you know the position for, you can say that the graph needs, the 000 point of the graph needs to be at this position in the scene. So then it plots the graph at that position, actually, essentially. So it acts as a separate 3D object. So you can imagine it as a 3D object which is placed.
I'm going to ask it as a newbie to VR. That is there any kind of like lessons learned based on the things that you experienced in VR, especially working with React and D3?
One thing is that it runs on the browser. So you need a really powerful, not a really powerful laptop, but you need laptops which to view this with some GPU capacity. One is that. Are you asking in terms of development or in terms of usability? Okay. In terms of usability, it's a bit hard to define interactions in VR. because there are many ways you can say that a user can interact. And for example, this mouse over functionality which I mentioned, it was like really hard for me to decide where to place the information about the data point, because if you put it on the data point, it can be occluded by other data sets, so you won't even see it. If you put it somewhere in the scene, you might be that you are not facing that direction, so you won't see it. So one idea is to attach it to the body of the user. So you just attach it to one of the controllers or to the head. So there are these kinds of things which happens with VR. And then there's also, which I mentioned about simulation sickness, like motion sickness, that you can't expect user to be in VR for more than, at least my experience was that I couldn't stand there for more than 10 minutes. One was that headsets are heavy right now, so it takes a burden, and also I wear glasses, so I have to wear it on my glasses, which also causes some issue. So there are these kinds of things. And development-wise, I think so A-Frame is pretty mature, and they have like enough documentation and stuff. So A-Frame is a good tool for WebVR stuff, and it's actually based on 3.js. So you can create your own components, A-Frame components. So right now they just have like box and spheres and these things, but you can define, if you are good at like 3D, like 3.js, you can define your own shapes and things. So you can say that I want, let's say, a flower kind of a shape which is created programmatically in 3.js. You can do that, and then you can import it as a A-Frame component and then use it here. So there are these kinds of advantages there in a way. The documentation is pretty good actually. So
you did this as part of your master's
Yeah.
thesis, but have you continued developing this further?
yes, so currently I'm basically trying to create a, so I'm not developing the library right now. I'm trying to create a online tool where users can upload their data and see the visualization by just publishing it. So they can like define like what is the mapping they want to do, with which column they want to map. For example, in a bar chart, what should map to the x-axis, what should map to the y-axis, and what should map to the z height of the bar charts. And then they can see the visualization there, and if they want, they can download it. One thing I forgot to mention with A-Frame is that since it's WebVR, they have this feature called as inspect 3D elements. So you can actually inspect the 3D scene per se. And what you can do is you can also download your 3D object which you have created in VR. So basically you can inspect the scene, so it's like really good for debugging and stuff to see where you are and how the scene is reacting. And then you can actually download the whole scene as a 3D object, and then it can be used, for example, for 3D printing your data set for creating like physical visualizations also. That was another good thing which I wanted to try out, but I haven't been able to print something right now.
All right, thank you. One more time, applause.
Thank you.
Thank you, Mustafa.